All right, what is the smallest possible thing you can even imagine? I'm not just talking small, I mean the absolute starting point of, well, everything. So let's get into it. Today, we're on a search for something so fundamental, you kind of have to wonder if it's even a thing at all. We're on the hunt for the zero-dimensional dot.
And this question right here. But where is it? I mean, that's really at the heart of our whole search. Think about it. If we're talking about the absolute smallest distinction, that teeny tiny border between nothing and something, where on earth could you possibly find it? It's a riddle, right? One that kind of makes you rethink the very nature of space.
Okay, so let's treat this like a proper investigation. Here's our case file. The objective is pretty clear. We're looking for this smallest possible distinction. That's the goal. We're on the hunt for the fundamental unit, the thing that separates one thing from another, or even something from, well, nothing. That's our target.
And here we have it, our main suspect, the zero-dimensional dot. Now, in theory, this is the ultimate starting point. Just try to picture this, a location in space that you can point to, but it has absolutely no size. I mean, no length, no width, no depth, nothing. It exists as a coordinate, sure, but it occupies zero space. I mean, how is that even possible?
And that's the real challenge, isn't it? If you can't see it, if you can't measure it, if you can't hold it, where do you even start looking? Well, when the physical world doesn't seem to have the answers, we've got to turn to a place where these perfect, seemingly impossible ideas actually can exist. So our first stop is going to be the world of pure mathematics. This is a realm of just abstract perfection, A place where ideas don't have to follow the messy rules of physical reality. The thinking is, if a zero-dimensional dot exists anywhere, it's got to exist here as a perfect, logical concept.
Okay, let's see how this actually works. We're basically going to deconstruct space. So, you start with a 3D cube, right? It's got length, width, and depth. Now, let's slice away its depth. Boom, you've got a 2D square. Take away its width, and you're left with just a 1D line. So, what happens when you take away that final dimension, the length? You're left with our target, the zero-dimensional dot, a location with absolutely no extension in any direction at all.
So the crucial thing to understand here is that in the language of math, a dot isn't like a tiny speck of ink on a page. It's a pure idea. It's a coordinate, a specific address, like XYZ on a map. It tells you where something is, but the location itself has zero physical substance. So, okay, we found it in theory, but that just brings us right back to our original question. Where is it in the real world?
All right, so time to leave the clean, pristine world of ideas and get our hands dirty in the physical universe. Let's see if we can find any evidence of a true zero-dimensional point out here in the world of atoms and energy. And to do that, we first have to understand the basic, let's call it, texture of our reality.
This is really interesting because it boils down to two main possibilities for how our universe is built. On one hand, reality could be continuous. Think of it like a smooth ramp. You can be at any point along that ramp with an infinite number of spots between the top and the bottom. Or is reality discrete? More like a set of stairs. You can be on this step or the next step up, but there's absolutely nothing in between.
And what's fascinating is everywhere we look in our universe, it seems like we find stairs, not ramps. I mean, the screen you're watching this on isn't a smooth, continuous picture. It's made of tiny individual pixels. Matter itself is built from atoms. Even energy doesn't flow smoothly. It comes in these little packets called quanta. And get this, physics even suggests there might be a thing called the Planck length, which would be the shortest possible distance, a fundamental pixel of space itself.
So, what does all this mean for our search? Well, it means that in the physical world, we never actually seem to reach zero. Every fundamental particle, every packet of energy, no matter how tiny it is still a something. It has properties, it plays a role. It's a very, very tiny stair for sure, but it's not that dimensionless location between the stairs, so our dot is still proving elusive.
Okay, so we're at a really critical point in our investigation here. Let's recap. We've established that the dot is a perfect concept in math, but it has no physical substance. And we found that the real world seems to be made of these discrete somethings, not sizeless points. So we're right back to our original question. But now there's a twist. Maybe we've been asking the wrong thing. Maybe all this time we've been asking, where is it? When we should have been asking, what is it?
And that leads us to our final verdict. Maybe we've been searching in the wrong way this whole time. We've been looking for a location, a physical destination on a map. But what if the dot isn't a place at all? What if it's something else entirely? So here's the big breakthrough. We have to completely abandon the idea of the dot as a physical spot we can pinpoint on a map. It's not some object hiding out there in the cosmos. Trying to find it, it's like trying to find the actual edge of a shadow. You can see where it starts, but you can't pick up the edge itself.
And here's the answer. The dot is the transition itself. It's the boundary line. It's not a thing, it's the very act of making a distinction. It's that conceptual moment where one thing ends and another begins. It's the switch flipping from off to on. It's the pure idea of separation.
And this brings us to this really profound final thought. The zero-dimensional dot is that abstract boundary, the transition from nothing to something, from continuous to discrete. It's the very definition of change itself. So where is it? Well, it's everywhere and nowhere. It's in every single distinction, every beginning, every pixel on your screen, every single quantum leap. It isn't a point in space, it is the very concept that allows space, and everything in it, to exist in the first place.